Some APIs support streaming. It takes a bit of extra work to integrate with that. In this module, you will learn what that entails. I'm Kevin and I'll guide you through it. We'll start with a few words on streaming and how that exactly is supported in .NET. After that, we will integrate our demo client with the streaming API endpoint. Let's dive in. Streaming is essentially a method of transmitting or receiving data over a network as a steady, continuous flow instead of all at once. It's often used for video and audio, which allows playback to start while the rest of the data is still being received. These days though, as applications often work on large sets of data, streaming is becoming useful for web APIs that return JSON. We're looking at a streaming endpoint as supported by our demo API. Once we send a request, results start coming in one by one. They are streamed to the consumer of the API, which in this case is the browser. Support for this is relatively new. It's thanks to the support for the async enumerable, available since ASP.NET Core 3, and system.text.json that has changed to accommodate for that in ASP.NET Core 6, that this is possible. If we have a quick look at the API code, you can see that it starts at the lowest level when accessing data. Here we return an async enumerable. In the related controller action, results are yielded one by one to the consumer of the API. Now, this is of course on working with HTTP client and not on building APIs. If you're interested in the details of how all of this works and how to implement it, have a look at my Developing an Asynchronous API in ASP.NET Core course here at Pluralsight. I won't get into those details here, but I did want to show you this so you can see that this really is data asynchronously streaming from the data store right up to the client. Speaking of that client, we shouldn't just integrate this using HTTP client like we did up until now. Whatever we use to handle this at level of the client needs to support this. If we simply deserialize the movie stream to an enumerable of movie, the client will wait until all the movies have come in before continuing, and that means we're not streaming at client level. So we need something else. Support for this for HTTP client is provided by two components. The first one is the iasync enumerable interface, the same one as is used at level of the API. As mentioned, it's been around since .NET Core 3. Its purpose is to provide the ability to iterate over a set of values asynchronously. And 2 is support for streaming in system.text.json. What you get when you combine these is a set of objects being streamed from the response to whatever code we write to asynchronously consume it. So we are going to asynchronously iterate over the incoming objects from the movie stream one by one. Let's have a look at that with a demo. In this demo, we will integrate with a streaming API endpoint in a way that allows us to continue to work with the stream while it's coming in. I'll integrate with the movies stream endpoint we've seen in the previous clip. Just to show you that you can integrate with it using the same type of code we've written before, let me paste in an example of that in the remote streaming samples class. Nothing of this is new. Let's run through it. So I injected the HTTP client factory and the options wrapper, as we will need these dependencies. The logic is in the getStreamingMoviesAsync method, which is called from runAsync. I create a new HTTP request message to get the movies stream and I send it. Important to notice is that I pass through HTTP completion option dot response headers read. This is important because we want to start working with the result before it has completely come in. Then I deserialize and write out the movie titles one by one. If we are not streaming, we will see all of them appear at visually the same moment. If we are streaming, we should see them appear one by one, as the API streams one movie each 500 milliseconds due to the delay I added at API level to make us able to visually confirm what happens. Let's open the program class and ensure that we use our remote streaming samples service. There we go. And let's give this a try. Our code works, but we are not streaming at level of the client. The serializer simply waits until the full response is here, and because of that we see all these movie titles appear at the same time. Back to our code. Let's comment out the regular deserialization. Instead of calling deserialize or deserialize async, we will call into deserialize async enumerable. This deserializes into an async enumerable, and it expects a stream as input. So we get the response stream first by calling read as stream async on the response's content. And then we want to write out each movie from our async enumerable of movie. So we can no longer iterate over it as we were used to, but instead, as we're iterating over an async enumerable, we need to await our for each. This should be it. Let's give this a try. And that's kind of odd. This doesn't seem to be streaming. All the movie titles appeared at the same time again. Behind the scenes though, it in fact is streaming. It's just not visible to us because the data isn't written to the console output window until system.text.json's buffer is full. By default that's 16 kilobytes, which is a little bit too much to make this visible with just a few movie titles. We can manipulate that. And we can do that on the options. We pass through the options object from the JSON serializer options wrapper. So let's navigate to that. And let's set the default buffer size for demo purposes to 10 bytes. And let's give this another try. And there we go. We now see the movie titles coming in, streaming. That's pretty cool, right? That's already it for this short module. Let's have a look at the summary. In this module we learned about streaming, which is a method of transmitting or receiving data over a network as a steady continuous flow instead of all at once. It allows us to already execute code on part of the result while the rest of the data is still being received. Support for this for HTTP client is provided via two things. One, the iAsync enumerable interface. It's been around since .NET Core 3 and its purpose is to provide the ability to iterate over a set of values asynchronously. When we call into deserialize async enumerable, the result is such an async enumerable. And 2 is support for streaming in system.text.json. That's built in since .NET 6. What you get when you combine these is the ability to asynchronously iterate over the incoming objects one by one, as we did in the demo. We've been working with ways to improve performance and lower memory use in this and the previous module. In that regard, there's another thing to look into: compression. Let's check that out next. Another way to improve performance is by supporting compression. That's what this module is all about. We'll start with a few words on compression, and then we will implement support for it when getting data and when sending data. Let's dive in. We've been sending data over the wire as JSON, in other words, as an uncompressed set of characters. Just as we can compress files on our machines, we can also compress whatever is sent from the API to the client and decompress it once it reaches the client, or the other way around. By doing so, the data that is sent over the wire is smaller, which results in less bandwidth consumption and thus faster overall performance. The API, or the web server where the API is deployed, depending on which component in your system you want to make responsible for compression and decompression, needs to support this though. Our API does, so we are good in this regard. Common compression formats are gzip or deflate. We can ask for a compressed response from the API by setting the accept encoding header to a compression format we want to accept, and which is supported by the API. At client level, the response should then be decompressed. We can enable automatic decompression on the built-in sockets HTTP handler. As far as sending data goes, it's exactly the other way around. It's up to the client to compress the request body. There's built-in stream variation classes like gzip stream and deflate stream that help with that. The content encoding header is used to tell the API which encoding it should use for decompression. Let's cover both in the upcoming demos.